Okay, we said in the previous video that a rational number means a number that can be written as a fraction, okay? Now, when we have fractions in general, we don't like to have square roots in the denominator, okay? It's messy. You can't really do a lot with them if there's a square root in the denominator. So we do prefer to have a rational denominator, okay? So a rational denominator means that there's no square roots. Okay, and we do prefer that you do this, and this is actually a normal maths convention that we never write a fraction with a root in the denominator, the same as we never write a fraction with a decimal in it. Okay, so what we're going to teach you today is how to rationalize the denominator. So let's say that we have an example such as 1 divided by root 2. Okay, so this is a pretty simple one. All we need to think about is how we can make that root 2 go away. Okay, now the typical answer people say is, oh, if we square the whole thing, so if we take the thing and we square it, then the denominator is no longer a root. And that's correct. However, if we square it, that means that we square the bottom, which means the denominator is going to be times root 2. And if we square the top, we're actually timesing by 1. Okay, and by doing that, this term here is not 1. So this is something that we can't do, because then we're not actually multiplying by 1, which means we're changing the whole value of our fraction. Okay, so instead of multiplying and instead of squaring, what we actually do is we just multiply by root 2 divided by root 2. Okay, so have a look at what's in the denominator, multiply by that number. Okay, now what we get as a result of this, in this case, is the numerator will now be 1 times root 2, so just root 2. Okay, the denominator is root 2 times root 2, and that answer is 2. Okay, so we get a nice answer here. We get a half root 2, and this is our answer. This is now with a rational denominator. You can also leave it as root 2 over 2. That's also perfectly fine. So either of those answers is fine for this. Okay, it depends what you want to use it for as to whether you'll leave it in whichever form. Okay, so this is basically it. It doesn't really get much harder than this. So for example, if I gave you, I don't know, what could we do? We could do 3 root 2 divided by 4 root 3. So let's have a look at this one. Okay, now we know straight away that the first thing we're going to do is look at the denominator and look at what root we have. So we have here root 3. We want that to go away. So we're going to multiply it by root 3, which means we're also going to multiply the numerator by root 3. Okay, so we get 3 times root 2 times root 3. So root 2, root 3. We'll look at that in a little bit. And then in the denominator we have 4, and root 3 times root 3 is just 3. Okay, now I'm not going to do any cancellation. I'm not going to do 4 times 3 yet, okay, because we're going to have a look at that in a sec. So we have 3. Root 2 times root 3. We learned in a previous video that the root of 2 times the root of 3 is equal to the root of 2 times 3. And in this case, that's the root of 6. So we have in the numerator 3 root 6 divided by 4 times 3. Hopefully you can now see that we have 3 times something and 3 times something. So we can cancel those 3's out because 3 divided by 3 is 1. So now what we have is root 6 divided by 4, or 1/4 root 6, depending on what you want to use it for as to which way you want to write it. But this is what we call rationalizing the denominator, and this is basically it. We can give you harder ones, however, at this stage we're not going to do that with you. That's something you'll probably do next year. Okay, so it's not really so important that you do the harder ones for now. This is, yeah, how it goes. Okay, so the rule basically is we no longer want to ever see you write a root in the denominator. You must always get rid of it. You must always rationalize that denominator, and this is the technique you use to do it.